Hello, and thank you for joining me as we continue our discussion on Newton's laws of motion. Today we're going to talk about Newton's third law. So Newton's third law deals with pairs of forces. So we have these forces we call action-reaction forces. So first, imagine kicking a soccer ball. So you kick a soccer ball into the air, and the moment you kick the ball, so you kick the ball with a force, say, of 10 newtons vertically, upwards here. So this is 10 newtons upwards. Oops, I got the newtons, I forgot the 10. So 10 newtons upwards. The ball at the exact same time is going to exert a force of 10 newtons on your foot. And this is an example, and this is showing Newton's third law. The force you kick the ball with is called the action force. This is the intended force. This is the one that most people see. So the exerted force is the action force. The reaction force is not the ball goes flying. The force exerted by the ball on your foot is your reaction force. So force exerted by the ball on your foot is your reaction force. So the action force is the foot hitting the ball. The reaction force is the ball hitting the foot. This is an example of Newton's third law, which is called the law of action-reaction. So his law, so you can get it written down, Newton's third law states that for every action or every action force, there's an equal and opposite reaction or reaction force. For every action, there's an equal and opposite reaction. We kind of implied the actions and reactions are forces. So if you want to write force behind it, you may. So when one object exerts a force on a second object, the second object exerts a force equal in size, opposite in direction on the first object at the same time. And these forces always occur in pairs, so we call them action-reaction pairs. Even if there's no motion, for example, if you push on a wall, you push on the wall pushes on you, no motion is happening, but there's still forces. Another example is when you sit in a chair. Your weight pushes down on the chair. So we have a chair, a very well-drawn chair. Your weight is pushing down this way. The chair is pushing up this way with an equal and opposite force. So your weight pushes down on the chair, and the force of your weight is the action force. So you caused this to happen. You sat on the chair, you exerted the initial force. The chair pushing back up on you with an equal and opposite force is called the reaction force. So that's where we get equal and opposite. In this case, there is no motion happening, but those are still equal and opposite pairs. Forces don't always have equal effects though. So even though there's always an action and a reaction, the effects are not always equal. So for example, you in the chair, they have equal effects that nothing takes place, you don't see anything happening. In the case of, say, you drop a ball towards Earth. You drop a ball, the pull of Earth's gravity is what you're going to see. So Earth's gravity pulls the ball downward. We all know that happens. If you don't believe me, hold your pen up in the air and drop it and see what happens. Your object is going to fall towards the Earth. What we don't see is the reaction force. So as Earth pulls the ball downward, at the same time, with the same amount of force, your ball is pulling the Earth upward. So I have the Earth, I have a ball, not drawn to scale. But Earth pulls the ball this way, and the ball pulls the Earth that way with the same amount of force. The forces are going to be equal, but think back, Newton's second law had an equation that was force equals mass times acceleration. Because the Earth has a much larger mass than anything that falls towards it, this mass is really big. When mass is really big, acceleration's got to be really small. So we don't see the Earth moving. So it's very easy to see the action force. It's easy to see this, but because of the relationship between mass and acceleration, we often don't see the reaction force. So again, Earth's mass is so much bigger that you can't detect the acceleration. It's so small it doesn't even show up. But let's do some practice with identifying action-reaction forces. So we've seen the Earth pulls the ball downward is the action force, the ball pulls the Earth upwards, the reaction force. So let's do some practice. I will do the first one with you, and the rest of them I'll give you to do on your own. I have answers on the next slide, so if you want to pause this after I do this first one and answer these and then check yourself, you may do so. So a ball bounces on the floor. So what's happening is we have a ball that's going to bounce, and then it's going to hit and go this way, and it's going to bounce, so on and so forth. What happens when this takes place? So my action force, the ball is hitting the earth, or ball strikes earth. I'm gonna say ball hits earth. I'm gonna call that my action force. My reaction force, as the ball hits the earth, or the floor, yeah, we could say earth, we should say floor. Ball hits the floor. The reaction force is going to be that the floor hits the ball. So you'll notice what I did there is I took this noun, and I flipped them so they're on opposite sides of the verb. So I moved floor to the front and ball to the back. That's how you set up action reaction forces. So take a minute, pause this video, answer questions 2, 3, and 4, and then I'll give you answers on the next slide. So here are your answers to those. So the first one was the ball hits the floor, the floor hits the ball. The second one, the action force is the bat hits the ball. The reaction force is not the ball flies, it's that the ball hits the bat. A sprinter runs down the track. So I have a foot pushing against the ground as my action force. The reaction force is the ground pushing the foot. And then last but not least, Conor McGregor punches his opponent in the face. So you have a fist hit a face as the action, and the reaction is going to be the face hits the fist. All right. One last question for you to try on your own. I want you to, and kind of questions and review everything. I want you to state Newton's third law, and then come up with your own example of where this is seen. So give me an action-reaction pair and identify, I want you to identify both the action and reaction forces in your example. Thank you very much for your time and attention. Enjoy the rest of your day. I will see you next time.